Hi and welcome. So this has been one heck of a week at work, so I'm a little late in delivering this video, but hopefully it'll be worth it. It's just a bunch of tools that I've got recently and a couple simple projects. First of all, I've been using boring bar like this for quite a while. It's got relatively inexpensive triangular inserts, and there's a lot of support under the insert, so you can get a lot of cutting force without much deflection. However, there is a side effect to having all of this backup behind the support behind the actual cutter, and that is that there's not a clearance for chips if they decide to go between the wall of what you're cutting and the tip here. So you can just see there's barely any clearance there. And I was cutting some aluminum recently for a project that I'm going to make a duplicate of today, and ran into some problems. So I decided to switch to this kind of boring bar. Now there's a couple limitations. One, these are both 3/4 inch boring bars, but the amount of meat on the end of this one is significantly more and stiffer. But there's a lot more clearance between the cutter and the wall of what you're cutting, so hopefully that'll help. This is a positive rake aluminum insert. I guess let's see if you can see that here. It also supports, this is a positive rake holder too, because you can see that this is sloped up. So this is designed for low cutting forces. It is a solid carbide bar, and the combination hopefully lets you cut rather deeply, although this isn't a particularly long bar. But if I held it back here, I think I could get 2 or 3 inches easy, which is handy. So I got this to try that out, and we'll give that a shot coming up. I'm always looking for carbide drill bits, which are crazy expensive. This was an eBay find, and I bought this lot of used carbide drill bits for, I think it was about $28, which is probably around the price of one, and the state of these, or condition rather, is pretty darn good. I was looking through a bunch of them here, like this fairly big one, and you can see that they're still really sharp, so these are in great shape. So this was a good find. Always check out eBay. I have multiple continuous queries for new items in particular, so I'm always keeping an eye out for things like this. It looks like a spotting drill, solid carbide. Pretty handy. Anyways, it was a good deal because, again, buying these individually, probably the same price would be for one. So we've got here an assortment of retaining rings, and these are assortments you can buy at Harbor Freight fairly inexpensively. But what the tool I'm reviewing here is not to cover the rings themselves. They're kind of mundane, and there's all kinds of resources to get those. But it is to find tools to insert them. So these are called, in the vernacular, Jesus clips, because when you're trying to insert one, more often than you'd care to talk about, you get it partway on, and then this shoots off somewhere in your shop, and you can't find it, and you exclaim loudly, Jesus. Anyways, without being sacrilegious there. This tool is designed to help you install them, and it comes with various different sizes of E-clip inserting tools, and you basically these are slightly spring-loaded, and you just insert this guy in here, and it will cup it and support it. I think this is not exactly the right size for this one, but this set comes in a variety of sizes here that are numbered. I wasn't aware that these had number sizes, but I guess it makes sense. This is number 4.0, this is 5.0, maybe that's in millimeters. So I guess this little one here probably would fit. See, it just did exactly what I'm saying, just loading it up. But you pop the clip in here, and then you can insert it on your part, hopefully with less drama. So there you go. So you can see they have a little lip that holds the clip to support it, which is kind of a nice design. I think I found this on Amazon. I don't know who the manufacturer is, but there you go, if you can find yourself one. Pretty handy. All right, so next up we have snap rings, which I've shown before and everyone's probably fairly familiar with. I had a set of snap ring pliers that I bought at Harbor Freight. that I was using with these for years, and they were total crap. The amount of force it takes to either open or close the snap ring, depending on which style. So this is an internal snap ring, and you squeeze this together, and that makes the ring smaller in diameter, and you can fit inside a cylinder, and then it'll fit in a groove inside and hold something in. The external snap rings, you open up, and they fit around something and fit in a groove on the outside. So with these guys, you need to close them together, and with these guys, you need to open them up. So the snap ring pliers from Harbor Freight had a neat feature where the pivot point was a pin that unscrewed. So when you squeeze them together like this, they closed the 2 points together, and then it had an offset where the pin would go over here, and when you squeeze them, it opens them up. It made them dual purpose, but they were soft, mild steel, and they really sucked. The pins would bend just with the amount of force it takes to open the snap ring. So the Knipex sets here that I bought come in a variety of sizes. You've got the straight ones and bent ones, and actually it's 2 sets of 4. So it's interesting how they've got them lined, even though they're different sizes. So with like this one, you see when I squeeze it, it opens up. When I squeeze this one, it also opens up. This one, when I squeeze it, it closes together. And when I squeeze this one, it closes together. So they're bent and straight. And that had me confused a little bit here. So for the external snap ring, you can see that the pins are even at a slight angle on this. Hopefully you can. And you pop the pins in here, and the snap ring stays in place, and then you can squeeze and open it up, no problem. With the Harbor Freight, they were straight, and when they'd bend, then the snap ring would just fly off. Now with this one, when you squeeze it, it comes together. So this is set up for an internal snap ring. And there's 2 variations. See, this opens up like that. And so with this one, there's 2 variations. You have also a set of straight that'll squeeze together if you need to reach deeper in, like this. And that lets me do an internal snap ring as well. And then this bent set that will also work for an external set, like this, that's bent. So this set, even though they've got different diameters, 19 to 60 millimeter, actually these are all numbered the same. The small ones are not, 10 to 25 and 12 to 25. Maybe that's because of the size of the arms on these, but these are also dual sets. So squeeze both of these and they open up, squeeze both of these and they close. So those two sets are really handy. This actually all came as one kit, and I again found them on Amazon. So really handy to have around, and a heck of a lot better made than the Harbor Freight. And at work, I have a set of snap-on ring pliers that are closer to the Harbor Freight design, and they were better built than the Harbor Freight because they were hardened. But these Knipex are light years better than either of those sets. So I recommend them. I think they're pretty fantastic. Next up is this pin spanner set. And over the years, I've had some fixed pin spanners that come with tools, but they're very single purposed. So either the pin diameters would not match the next part you wanted to try and unloosen, or they would be not open up enough. Or while you're squeezing them, they would just slip one pin off because you're at a slight angle because you're trying to wrench on something. So I found this set on Amazon. It wasn't inexpensive, but it's really well made. And the arms open with a left thread and a right-hand thread all on the same thing, which is pretty neat. And you'll notice the pins stick out both sides. That's because these insert pins that unscrew are 2 different diameter pins. So you can use this. You can use this to open up a bunch of different sizes, and it comes with a whole bunch of different pin sizes that are all by 2-sided. So that you can work either direction. You could also screw it on the other side if it's more convenient that way. Like I said, this set was not cheap. I think it was $70 or $80, which I guess really is cheap if you considered having to make it yourself and how many hours it would take to put in to make this set. But it's got a large ranges of sizes of pins, and I think it's also a good deal. I think it was around 80 bucks on Amazon. So recommended. Among other things, I could have really used this on my milling machine when I was taking off the nut on the bottom of the spindle. Next up, for threaded rod, round threaded rod for those people working out in the field, I showed a deburring tool that was $3. That was a total piece of crap, but worked. It took a lot of force. Here is a better version, and I ran across this at the Barzy Bash. And this one's pretty nicely made. It's hardened steel, unlike the other one that was just chromed. So they were relying on the chrome being the strength, which is really weird to me that they would even consider that. This also has a hex shaft. It's pretty lightweight, and the internal parts are, the slots are pretty darn sharp. So there's another thing to look at. I haven't had a lot of time on this one yet, so I can't suggest it or, you know, say don't get it, but there's just another option out there if you're looking. Apparently there's a few of these different manufacturers. There's even one that's got brazed carbide inserts, although they didn't look like they did a particularly good job of brazing them, not neatly anyways, but maybe very functional. So all right, I think that's about it for the tools. Let's move on. Next up is a couple quick projects. So this is not a to scale part. This is actually a PNG drawing, graphic that he sent me, not a CAD drawing. These are some parts for a customer, one of my Craigslist customers. He had them made by another machinist, and it was really strange because these parts are 2-inch diameter, and so he used 2-inch rod stock diameter, which means, you know, these aren't always perfectly round, these extruded aluminum rounds. And it was off by quite a bit as you go around, plus the finish, not great. Also, instead of a 3/4 inch hole like it's spec'd here, it was 0.6 and change. I don't quite get, like 0.64, don't quite get that. This depth was 0.5 something. Instead of 0.625. So I don't know, maybe, you know, I really don't actually understand how it ended up like that, but he came to me to make the parts better because nothing was fitting right. So I'm going to start with some 2¼ inch stock here, turn this down to the 2-inch diameter, get it fairly close, drill out the 3/4 inch hole. This does not need to be bored because it does not need to be a clean finished hole. He didn't, this actually has some bearings that need to fit in here in a sloppy fashion. So the bearings are 1.626, 1.624 and a half rather, in diameter. And he wants them to be a sliding fit. So I'm going 3/1000ths over this, diameter wise, so that they just slide right in. What he didn't count on is you need a relief for the inner race so that it doesn't rub because the outer race is touching here. So I added a 20/1000ths depth by 0.3 off center relief for the center part of the bearing. So we're going to make one of these parts out of this piece of stock here, and that is one. And then the other quick project is these are microphones. This is for work, believe it or not. These are microphone adapters, and these are the 5/8 27 threads that are standard for microphone clips. How they came up with that, you'll never know. Probably because someone wanted to keep it proprietary and prevent other people from making them. So we're going to take these, we're going to drill this out, and we're going to make it 1/2" 13 because we're actually using, because although this was originally designed for microphones, I have some VESA monitor mounts that need to go up, and these are monitors that hang in the green beds. Green beds are where the audio guys boom from up high, so they're above the set, and they can get the microphone down into the set without being in the shot of the cameras. So I need to make some adapters so that we can hang some monitors for them to see, to make sure they're not in the shot. And so I need to drill these out and then tap them 1/2" 13 on the inside, which just leaves just enough meat for these to be good. So in order to do that, I made this adapter, and I have the 5/8 27 thread tap, which I tapped the inside of this. And so I drilled the clearance hole for the 1/2" tap much deeper. And what you do is you chuck this guy up, and you thread these guys in. These are some new ones that I just bought. They're a little bit tighter. And then I took one of the service grinder and ground this tool to use as a screwdriver to tighten these guys down. And if I was going to do more of these than just the 15 I'm planning on doing right now, I would I'd make some sort of handle to fit around this, because this isn't particularly comfortable. It just works. This is too long for a too wide for a screwdriver, even really large screwdrivers. So we'll probably start with these, and then we'll switch over and do this guy. All right, so these inserts are steel. The other ones I've dealt with are all aluminum. So this one, I am going to shoot, you know, there's different thread depths you can go for depending on how hard the material is, and you'll still end up with very strong threads. So for aluminum, one of the charts I have recommends 75% depth of thread, and for steel, 50%. So this is 50%. So this is a slightly larger drill bit, and I don't know if I need to step through drill sizes on this. We're gonna go slowly, and we're just gonna try and drill this guy out here. Oh, it doesn't look like that's happening, does it? Or maybe. I wanted to power tap these because I have so many of them to do. And we're through. That was not a gentle process there, and I did that without lube. That was at 70 RPMs. So let's see if we can power tap these guys. We probably want to chamfer that first. So these will be somewhat shallow threads. So the question is this just too much to power tap? I don't know the answer to that, but we're going to find out. That's one of the reasons I chose 50% threads, so that it wouldn't be so much force on the tap. So looks like it's working great, if I can get it out when I'm done. I've got a jog button on my lathe, and it actually is jog in reverse from whatever direction you're going. Okay, that looked like it worked pretty good. All right, let's see how tight those threads are. Well, that feels really good. And considering these are steel and the other ones were aluminum, I think these are going to be plenty strong. So that's holding really nicely. So I think we're going to go with this. Now I guess one more thing we need to find out is, am I going to be able to unscrew this with my tool? Or did the drilling process make it so tight? Yeah, it made it really tight. Kind of get a handle on this. Well, okay, so that's a problem. The power tapping and drilling process, it made this thin so that you have nothing to grab on anymore. And it's kind of weak. The aluminum ones, this was not a problem, but the steel ones, it seems like it's going to be a problem. I might have to manually tap these. This guy worked perfectly well with the aluminum inserts, but being a piece of aluminum itself, I think it was so soft that there's some welding going on in here, and I can't get this guy out, so I'm gonna have to remake this part in steel. This is just cold rolled. And we're gonna go all the way through. So we're just boring out the outer section here. And I already cleared it mostly out. So I've got a bottoming tap here. So let's do a test fitting here. So I think that's good. And hopefully, being steel, I'll make sure to add some lubricant to the threads, but hopefully being steel, I won't have to worry about the threads binding with, or welding to the material like they did on the aluminum. So I think we're good to go here, and we're ready to drill and tap. Also, to keep the drilling forces down, I'm going to drill this, yuck, ugly. I'm going to drill this in two sections. I'm going to do the 3/8 inch hole and then the tap drill next. Hopefully that will make it less force and easier to get out. So there was the 3/8. Not a good sign though, that stuttering where it's catching on the cross slot might be a bit problematic. Let's add some lube this time. Yeah, I think that's what's catching it, and that's tightening it up. So I wonder if I'm even going to be able to get it out now. Once it's all drilled out, then we will power tap it. And I just leave the tailstock loose to do that. Now the big question is, will I be able to get it undone? Because that was our problem last time. And I think a better tool would be in order too than this one. But yes, we can undo these, no problem. That's not that bad at all. All right, so there we go. Drilled and tapped for 1/2 inch 13. Now I just need to make 15 more of them. In case you're wondering, there's a 1/2 inch 13. Here's the close-up of the fixture. So I made a flat bottom for it to seat up against, although the diameter difference is so close that it is problematic. That's why it cuts up the other side. It's just cold rolled steel, quick tool. So the main hole through it is clearance for the 1/2 inch tap, so I can go in past the starting threads onto good threads. And I didn't want it to go so deep that I caught too many threads on the part, so I could easily undo it. So far I was using this tool I made to unscrew these, and it was working fine when this material was thicker here and the threads were not sticking too much. But you can't really get a lot of force on this, so what instead I'm going to do is I'm going to make a piece that just fits down in here, and I'll hold from the beginning and give you a little more leverage with your fingers to hold on to. So all I need to do is take about 52 thousandths aside the width of this guy, and it'll help align it too. So that'll make a nice tool. I'm going to use this 7-flute carbide Invel, and it's not a super precise operation, fortunately. So we're going to find our Z0 here, and all I'm going to do is make a slot on both sides of this part that makes the center thickness, well, this is 82 thousandths, about 80 thousandths, so there's a little bit of slot. We'll do 25 thousandths a pass. So here's the new tool, and you can see it'll grab this while being flush on the top, and it's much bigger, so it's easier to get my hand around. So that'll be a nice addition, and it'll let me apply significantly more torque than this one, which also tends to slip out. Now the reason I made it so narrow is because when this actually gets installed on the other side, this piece needs to fit inside because the threads actually go below the surface. So that's why this one's narrow. So that'll be for that, but this will be to take it out of the lathe. Next up, we have the part from the Craigslist client. So the first thing I'm going to do is I'm going to face this guy off. To be honest, I could stop the facing right now because what in reality, all this inner part's going to be bored out, but I'm going to let it go. If I was trying to do this in a manufacturing, make lots of these, I'd be looking for every solution to make this go quicker or more quickly. So I've got my blast shield here to stop the chips from coming at me, because we're actually breaking chips right now. I think it's a little bit deeper than this insert's good for. That says it's 1/1000th over, and we'll leave it at that. Continuing saga. This is just under 1/2 inch 31/64 because it's a high helix cutter, so it ejects chips much more efficiently, but the internal web is much smaller in thickness, so it's weaker. They can break much more easily. Drilling for the final 3/4 inch diameter. Now again, if this needed to be a precision or smooth bore, I wouldn't be drilling to final size. I'd bore out the final size, but this is non-critical. It's for bolt clearance. So we can speed this operation up. And we're shooting for 625 deep, so we're going to stop at 600. There we go. And we're going to wait till we come out quite a ways before we bother starting to measure. This is one of the boring bars I was talking about that doesn't have a lot of clearance. Last 25 thousandths, so we're going to take at a slower pace here. This should give us a better finish, which it looks like it is. Unless some chips get trapped between the boring bar and the wall. The other parts I made for this guy, they were a lot deeper, and I had that problem. I left too much material. There's a bigger bite. So I can set my X0 again. So we'll set my X0. We're going to do the relief in the bottom now. So we're going to go in 20 thousandths, 30 thousandths, 300 thousandths out. And there we are. One side done. I just need to clean up this sharp edge here. A little sandpaper should work very nicely. This is a very shallow hole that I don't have to worry about my finger getting caught in, but you've always got to be very aware mentally when you're sticking your fingers in a hole with a moving part. That is a recipe for disaster. So when in doubt, don't do it. Okay, now we can cut this part. We can part this guy off. Flip it around, size it, and bore the other side out, and we will be done. Like I said, this is a quick part. Holds a couple of bearings with a 5/8 inch bolt down the middle. So again, we're not shooting for super precision here. Within a few thousandths is more than enough. So I lightly touch, get my Z0. The thickness is 0.1285. So I go over 0.1285, zero that out. And we want 2.5. And I will go 25 thousandths over 2.5, 2.525. And we're just going to part this guy off. And we're through. Facing off the other side to length. Not a precise measurement again, so I just use calipers. If you really wanted to be precise, you'd have to take this over to the surface plate, set up a set of gauge blocks with a dial indicator, and set your height and then compare. But this is within a few thousandths. It'll probably be within a thousandth when I'm done. final finish pass slowed the feed rate down. Also taking a smaller depth of cut, about 28 thousandths. So you get some chip packing because there's not enough clearance. And we need to do the inside relief. Feed out. I need to run the sandpaper on the inside. Got some chip welding on that last pass, of course, because the chips welded between the outside of the boring bar and the cutter. That's much better. That was really ugly in there. All right, let's pop this guy out. Here we go. Finished part. Got to just blow out the chips out of the middle. We should be good to go. Thanks for watching. Hope you found it interesting. Hope to see you next time.